Okay, this is going to be day 2 of your STAAR review. We're going to jump into the exponential functions. We're going to talk about exponents. We're going to talk about a lot of information. I apologize for not being able to be in class. Obviously, I would like to be there, especially with the STAAR test coming up, but life happens. So it kind of is what it is. For those of you guys, second hour, I'm actually recording it in front of you guys. Please, I know that you're going to hear it twice, but just pay attention, please, please, please. Like I've told you guys in class, the reason we're choosing this to go over is because it's a huge, huge part of what's going to be on the STAAR test. We tried to pick the 4 biggest sections: domain and range, exponential functions, linear, stuff like that. And we're trying to give you the most information that we possibly can to try to get you ready for this test, okay? So please, please, please pay close attention, okay? All right, so today we're going to talk about exponential functions. We're going to talk about exponent rules. We're going to talk about a few things: exponential growth, exponential decay, just everything that has to do with exponents. Hopefully, it doesn't take longer than 15, 20 minutes tops. If you want to go back and watch it, I would highly recommend you do that. After the assignment or after the video is done, there will be an assignment posted for you guys to work on. Again, honor system. Please just do things the right way, okay? Always. All right, here we go. Exponential functions. So here we go. Your equation is y equals abx. That's your exponential functions. Okay, so the first one, let's talk about the parts of it. The first one is the letter A, okay? This is your y-intercept, okay? So whatever number you start with, and we've talked about it in class a lot, your starting point, your starting number is always going to be your y-intercept, okay? Whatever number you start with. If you buy a car for $6,000 or whatever, that would be the starting point, okay? And then it either goes down from there or goes up from there depending on what you get, okay? All right, here we go. The y-intercept is the A. The B, that is going to be your growth or your decay. Now, if it's growth, this is what you guys want to remember, okay? Growth is going to be greater than 1. And if it's decay, it's going to be less than 1, okay? Growth and decay, think about it like this. If you multiply times the actual number 1, it's going to be the same number over and over again. 5 times 1 is 5. 5 times 1 is 5. So for it to change, it actually has to be above 1 or below 1. We'll get into that here in a minute. Hopefully you remember that, okay? Exponential growth, exponential decay. And then the x is the exponent of x, makes this an exponential function. So if we tell you what's the new value after 6 years, we would put a 6 in there for the exponent, okay? Here's how many times we're actually going to multiply or whatever. This is how many times we use that exponent. Hopefully that makes sense, okay? Exponential growth, exponential decay. I want to make sure we're covering everything. Everything looks good. All right, moving on. This is what we're talking about with the exponential growth or decay. Okay, so it's the same thing. It's the exact same thing. Y equals ABX, okay? But now, ABX. But now, instead of having the letter B, I'm going to put that in there, okay? So this is where your growth or decay comes from. This is where your growth or decay is going to come from, okay? So here's what it is. The A is the initial value. Okay, same thing that we just talked about. The initial value is your y-intercept. Okay, the initial value is your y-intercept. Now, here's where it's a little bit different. Your growth or your decay. The R is the rate of increase or decrease. So if it's increasing, I'm going to add. Okay, now remember, you would make it a decimal. If it's 25%, I would make it a 0.25. So your new rate would be 1 plus 0.25. Okay, we're going to have a practice problem here in a minute, okay? So rate of increase or decrease. So if it's increase, it's going to be a positive. If it's decrease, it's going to be a negative. So you would subtract it because we want to make it less than 1 because it's going down. Okay? Increase goes up. Decrease goes down. Okay? Pretty simple. Okay? Adding and subtracting. And the x is still the exact same thing. Okay? Well, there's our plus and minus. And then the x we've already talked about. All right, here we go. Joe purchases a car for $26,500. I'm going to grab a calculator real quick because I'm going to do it. I'm going to do the math with you. All right, here we go. The car, the key word, depreciates at a rate of 3% annually. How much is the car worth? Okay, so here we go. Purchases a car for $26,500. That is my starting value. Okay, that's what I went and bought a car for. Okay, so I would go $26,500. Now, if you guys remember, my equation was this. Y equals A, and then we did, what was it? Let's go back. I want to make sure I do this. 1 plus or minus 1 plus or minus the rate, and then the x, okay? Just to remember what we put. Now, this one says it depreciates. Okay, so depreciation, think about it. Does that sound like it goes up or does it go down? Depreciate means it's going to go down. Okay, so I'm going to use the minus. So here we go. Y equals 26,500. And then I'm going to go 1 minus a rate of 3% annually. Okay, 3% as a decimal is 0.03. Remember, you move the decimal twice, so that would be 1 minus 0.03. And they want to know what the car is worth after 5 years. So all I'm going to do is I'm going to take that 5 years and put it as an exponent. Okay? That's really all it is. Okay, so I'm just going to go to my handy dandy calculator and I'm going to type it in just like I see that. Okay, so here we go. 26,500 parentheses 1 minus 0.03 and then exponent of 5. So I'm going to hit, well, let's see, where'd it go? Oh, there it is. Above the division sign, we got that little caret. Okay, above the division, looks like this. It's above the division sign, so I'm going to go there, and I'm going to hit a 5. Make sure it's on the outside of the parentheses. My answer is $22,756.45. Let's just go ahead and make it 2 decimal places. There's my value. It went down 3% per year, and I'm going to look at it and make sure it makes sense. If I bought a car for $26,000, after 5 years it's worth $22,000, it kind of makes sense. Okay, so my answer actually feels pretty good. Okay, hopefully that makes sense. If you want to, go back and watch it again. Go back and watch it again if you need to. Okay, please, please, please. Starting value, 1 minus because it depreciates, and then 3%. So I made the 3% a decimal. Now, some of you guys might want to go 1 minus 0.03. You might actually put a 0.97 in there. It's the same thing. It's the exact same thing. If you just want to go ahead and solve 1 minus 0.03, whatever. You do you. You do you, boo. Okay. All right. Let's go on to the next one. Go on to the next one. Here we go. The population of a town is 22,640 people in 2015. The population of the town grows by 3% every year. What is the population in 2025? Okay, so what information is important? Now, here's what I want to do. Hopefully you have a piece of paper, okay? I want you to pause the video. I'm going to pause the video for a minute, okay? Or I would like the teacher or somebody to pause the video. I want you guys to try to set this thing up, okay? I want you to try to set up the equation using the starting number, okay? Is it appreciating? Is it depreciating? Is it going up? Is it going down? And how many years are we talking? Okay, look back at the problem, double check it. If you substitute, if you can do me a favor, just pause the video, let the students work for a second. But I want you guys to set this thing up on your own, okay? Awkward silence. No, it's not paused. Okay, I didn't pause. Hopefully the video got paused. If not, whatever. Okay, moving on. All right, here we go. My starting value is 22,640, right? 22,640, so that's my starting number. 22,640. Now, if you guys are in class, you can answer this too. Okay, the population of the town is growing, plus or negative, plus or minus. If it's growing, it's going to be plus, obviously. So I'm going to add 1 plus, because it grows, 3%, so 0.03. And now we got to figure out how many years we're talking, okay? Now, it doesn't make it wrong if you put the parentheses on the front number too. It doesn't make it wrong, okay? What the heck? Let's just get rid of the parentheses. So I think that's going to mess with some people. My starting number, here's my parentheses, because here's the equation. Y equals A, and then we have the 1 plus or minus the rate with the X, okay? All right, how many years are we talking? We went from 2015 up to 2025. So that is 10 years, obviously. Okay, so now we're going to get my calculator. See if we're right. Here we go. 22,640 parentheses. I'm just typing this in exactly as I see it on the calculator. I'm not changing anything. Okay. Here's an announcement. Waiting for the video. Waiting for the announcement. Surprise. Okay. All right, here we go. So now I'm going to finish typing it in. 22,640. And then I'm going to go parentheses 1 plus 0.03. Please remember, you got to make that a decimal. You have to make that a decimal. Okay. Close it, and I'm going to do with the exponent and put a 10 up there. My number, 30426, and the decimal is 0.3. Because we're talking people, I'm not going to use a decimal. So the anticipated amount of people, 30,426 people, which makes sense. Think about it. If it's growing over 10 years, does that number make sense? Yeah, kind of makes sense. So I'm going to feel pretty good about my answer. Okay. Make sure your answers make sense. If it tells you that it should be growing, but you got a smaller number, maybe you might want to look at it and say, you know what, I kind of messed up a little bit somewhere. Make sure your answer makes sense for what they are asking you, okay? All right, let's do another one, maybe. A scientist is trying to find a cure for the common cold. She takes 40 common cold cells and discovers the cells are tripling every hour. Okay, what are they going to be in 6 hours? So here we go. This one's going to be the y equals ABX. All right, here we go. It is tripling every hour. What's my starting number? So y equals my starting number. How many did she take? She took 40. So I'm going to start with the 40. Now, they are tripling. To triple, you multiply times what? Think. Anybody in class? When you're tripling, what is it? Times 3. So I'm just going to put a 3 in there. Okay? And then how many cells are there going to be in 6 hours? Okay, they're tripling every hour. Okay, here's the key. They're tripling every hour, 6 hours. So the 6 is going to be my exponent. This is going to be a big number. So check this out. Here we go. I'm just going to type that in, just like that. 40, parentheses, 3. Then I'm going to go exponent 6, 29,160. It tripled 6 times. Think about it. That seems like a stupid number, but if you want to, you can actually go 40 times 3, times 3, times 3, times 3. If you want to do it 6 times and get your number, you're more than welcome to check it if you would like to, okay? But that is actually the correct number, because numbers, if you think about it, the numbers that double, we did this in class. When they double over time, eventually it gets to some really, really big numbers, exponential growth, okay? All right, moving on. All right, a couple things. This is the little thing for examples. We're talking about exponent rules. On your paper, you need to write these down, please. These are very, very important. Now, don't write these down. These are just examples, but I'm going to give you the algebraic rule for each one of them, okay? So here we go. If you have x to the first power, any number to the first power is that number again. So if it's 5 to the first power or 6 to the first power, it's that number again. So basically everything, like the number 5 has an exponent of 1. You just never see it. You never see it, okay? All right, here we go. 0 power. This is one we talked about a ton in class. Anything to the 0 power is 1. Anything to the 0 power is 1. You guys that are watching me record, you guys remember that? 0 power is 1. That was on your test. I guarantee it's going to be on your STAAR test, okay? All right, here we go. Negative exponents. So if we got x to the negative third, what I'm going to do is I'm going to flip it. Okay, I'm going to flip it. So in this case, I'm going to put it on bottom. 1 over x to the positive third. Remember, if you have a negative exponent on bottom, you flip it to the top and just make it a positive. Okay, so an example of that would be like this. X to the second over y to the negative third. This one's okay. X to the second. Y to the negative third needs to go to the top. Y to the positive third. There's actually my answer. Negative exponents need to flip. Okay, so please, please, please remember that. All right, here we go. Next one. X to the second times x to the sixth is x to the eighth. You add the exponents together. When you multiply with a common base, you add the exponents together. When you multiply with a common base, you add the exponents together. Okay? This is the example they give. X to the 6th divided by x to the 3rd. Okay, so if you multiply, you add, what do you think you do when you divide? Subtract them. That one would be x to the 3rd power, 6 minus 3. Okay, and then the last one, x to the 3rd to the 5th power. When you have a power of a power, you multiply them together, you get x to the 15th. Okay, you just multiply the two numbers together, 3 times 5. Hopefully you guys remember that. If you need to, like I said, this is on a video, go back and watch it again. Okay, go back and watch it again. There's a lot of practice that you can do also. All right, we're almost done. We got a couple more. All right, first one. When you guys see these, okay, please remember, you're going to see one or two of these on the test. You're going to see, actually, you might see more than that. When you guys see these, please remember to go term by term at a time. Don't try to do too much at once. Please do not try to do too much at once, okay? That's where people start getting messed up, okay? So here we go. I'm going to start at the very front. And let's, for the heck of it, let's put a fraction. What is 30 divided by 5? All I'm focusing on is this right here. 30 divided by 5. What is that? That is 6. So I'm going to put a 6 right there. Okay? Now, letters. We got x to the 3rd over x to the 2nd. If you guys remember, it's kind of like this. X to the 3rd over x to the 2nd. If I cancel two of them out, how many are left? I've got one x left, and it is where? It's on top of the fraction, so this is going to be x to the 1st. Basically, what I just did was I subtracted 3 minus 2. That's all I did. So that's taken care of. Okay? I just realized there's another x up there at the top. That's fine. I'll take care of that in a minute. All right, here we go. So I've got y16, y5. If I subtract 16 minus 5, I get, anybody in here? 16 minus 5? 11. So it's going to be y to the 11th on top. Y to the 11th. Okay. Now, I've already got an x up here. I took care of this one. Here's where I messed up. This is my fault. Now, this is not by accident. I actually didn't see it. But now that I'm going term by term, I see it now. Okay, so it's an easy fix. I've already got an x up here, but I've now got this x to the 2nd power. So I've got two of them still up here, but I've already got one. So I'm just going to add it to the one that's already there. So my x is now going to be, it's now going to be an x to the 3rd power. I'm going to take that first power and the 2nd power, and I'm just going to add them together. Okay, so it should be x to the 3rd. Okay, or you can look at it like this. Here's what I didn't do. 3 and 2, that should have been x to the 5th power. And then I subtracted the 2. 5 minus 2 would have been 3. So either way you look at it, I still got 3 x's on top. Okay? All right, moving on. Last one. Last one and I'm done, guys. Hey, stay focused for me. I know you're getting tired. I know that the STAAR test, STAAR review is kind of annoying. By the way, if you guys are in this class right now, you can just kind of chill the rest of the hour, but don't disrupt while I'm doing the video, okay? All right, here we go. So I'm going to go term by term, okay? By the way, immediately I see the 0 power, yes? Okay? Now, if I look, the first thing I see is, you see this power of a power? You guys see this right here? I'm going to take care of that first, because before I can multiply, because of PEMDAS, what do I have to do before multiplying? I have to do the exponents. I got to take care of that exponent on the outside first, okay? So here we go. 2 squared is 4. 2 times 2 is x to the 4th power. That's done, that's done. 5 times 2 is y to the 10th. 4 times 2 is z to the 8th. Remember, power of a power, I just multiply, okay? Hopefully you guys are okay. If you need to, go back and watch it again. Power of a power, all I did was I multiplied the exponents, and then I just went 2 squared. That's where I got this 4, okay? Now, let's do this. 2, x2, y, negative 12, z to the 0 power. All right, here we go. Stick with me. It's not too crazy, okay? Just stick with me. It's not bad. All right, here we go. Numbers on the front. What's 4 times 2? 8. Those are done. Okay? When I multiply, I add the exponents together. Yes? When I multiply, I add the exponents. So here we go. What is 2 plus 4? X to the 6th. Those are done. Now, here's where it gets a little tricky. Just stick with me on this. Again, stick with me. Okay, here we go. I got negative 12 plus 10 because negative 12 plus 10 is negative 2, right? Don't let it freak you out yet. Don't let it freak you out. We're fine. We're good. And then I've got 0 and 8. Well, the 0 just pretty much means it doesn't exist, okay? So 0 plus 8 is z to the 8th power. Okay, so we're good so far. Now, those of you that are sitting here watching me, what's my issue with this answer? Any issues? I see a negative exponent. Do you guys remember what I just said about negative exponents? Anybody remember what I do? Say it. I flip it. So I'm just going to take, everything's going to look okay except for this. So what I'm going to do is I'm going to bring that down here, y to the second power, and I'm going to leave everything else the exact same. There it is. I can't have a negative exponent. So all I did was I just grabbed it, put it on bottom, and everything else stayed up there. Everything else is the exact same. Okay? Please, please, please pay attention to the rules. Okay? When you multiply, you add. When you divide, you subtract. Power over power, you multiply. Just go number by number, step by step. Okay? You're going to see a lot of exponents on this test. Okay? Don't let it freak you out. Don't forget exponential growth. Exponential growth, it's going to be greater than 1. If it's exponential decay, it's going to be less than 1. Here's growth. Growth looks like this. Okay, exponential decay looks like that. Okay, growth takes off. Decay looks like that. Okay. If you have any questions, email me. I'll be glad to come help you out as much as I can. If you want me to go back over some things, I will be back at school on Tuesday. Okay, you guys can come see me during advisory. Come get some help. Send me emails. I will do what I can to help you. Okay. The assignment, the teacher's actually going to have assignments for you guys. Please do me a favor, take those seriously, okay? Because like I said, this is important enough for me to go over it as a STAAR review and burn an entire day doing it. So we do need to make sure that we go over it, okay? Have a good day, guys.